So, we're going to take the unit circle, which relates sine, cosine, and an angle. That's three unknowns. We're going to take that and split it into functions. A function never has three unknowns. Okay, it only has two at a time. So, the unit circle is not a function. You can see that. It doesn't pass the vertical line test. We're going to take it and divide it up so that it is two functions. Okay, the unit circle relates three things: an angle measure, a cosine value, and a sine value, all at the same spot. Okay, we're going to split those up today. So we're going to fill in the unit circle to some extent. I have not put multiples of 6 on the unit circle because I think we can do this effectively without those. I think you can do it just with the multiples of pi over 4. So we need to fill in the ordered pairs and talk about what the ordered pairs give us and use that to create some graphs of sine and cosine. Ready? What is the ordered pair at the angle of 0? 1, 0. What does that give me? Okay, which is which?
Cosine, sine.
Cosine of 0 would be 1, and sine of 0 would be 0. The cosine of the angle is the x value on your unit circle. The sine of the angle is your y value on your unit circle, right? You're okay with that? Okay, so I can now start to fill in my table that I've set up at the same time that I'm making my unit circle's points. So the cosine of 0 we just decided was 1. The sine of 0 we just decided was 0. Let's go to pi over 4. What's the ordered pair that goes with pi over 4?
Square root of 3 over 2.
Square root of 2 over 2. And square root of 2 over 2. Remember, we skipped over the pi over 6 and pi over 3. Okay? So square root of 2 over 2 and square root of 2 over 2. I gave you a hint that you might be able to remember that pi over 4 gives you 2's because 2 goes into 4 evenly. Okay? 4 gives you a lot of 2's. So multiples of 4 gives you square roots of 2. So therefore, my cosine value at pi over 4 is square root of 2 over 2. My sine value at pi over 4 is also square root of 2 over 2. At pi over 2, what's my ordered pair on the unit circle?
0, 1.
0, 1. So that tells me my cosine value at pi over 2 is 0. My sine value at pi over 2 is 1. At 3 pi over 4, what's my ordered pair?
Negative square root of 2 over 2, 2 over 2.
Very good. Negative square root of 2 over 2, positive square root of 2 over 2. So the cosine value would be negative square root of 2 over 2. The sine value would be positive square root of 2 over 2. My ordered pair at pi is what?
0, or negative 1, 0.
Negative 1, 0. So my cosine value at pi is negative 1. My sine value at pi is 0. My 5 pi over 4 angle has an ordered pair of what?
Negative square root of 2 over 2, negative square root of 2 over 2.
Very good. Okay, so my cosine value would be negative square root of 2 over 2, and my sine value is also negative square root of 2 over 2 at 5 pi over 4. 3 pi over 2 gives me an ordered pair of what?
0, negative 1.
Which tells me my cosine value of 3 pi over 2 is 0. My sine value of 3 pi over 2 is negative 1. 7 pi over 4 gives me an ordered pair of?
Square root of 2 over 2, negative square root of 2.
Good. Square root of 2 over 2, negative square root of 2 over 2. So therefore my cosine value is positive square root of 2 over 2. My sine value is negative square root of 2 over 2. At 2 pi, I'm back to the ordered pair of 1, 0. So my 2 pi gives me an ordered pair or cosine value of 1 and a sine value of 0. Now, my unit circle does not have to stop there. It is actually infinite. I can keep going past 2 pi. My next angle marked on the unit circle would be 9 pi over 4, and I would have the same sine and cosine values. My values would start to repeat. So I would start to repeat the cycle. Sine and cosine are cyclic functions. I think these are the first cyclic functions that you have in your math career. And that means that they have a period length. The period is how long the cycle is, or how long it takes for the number pattern to repeat. Okay? So how long does it take before cosine and sine values repeat the pattern? Everybody got it or no?
Every 3.
Now I know that you have duplicate values within here, but the entire pattern has to be copied. Does that make sense?
Yeah,
8 sections, which is also 2 pi. It takes 2 pi units before your sine and cosine cycle repeats. So the period length is going to be 2 pi. You'll see that in a minute, okay? But sine and cosine are cyclic. What we're going to do is we're going to dissect this table right here, and we're going to make a new graph of just cosine. So now I'm going to graph the function. This is going to pass the vertical line test. I'm going to graph the function y equals cosine of x. What I've done is I've changed the equation. This y value is no longer going to be the same as this y value over here. This x value is no longer going to be the same as this x value over here. This y value is going to measure the cosine of an angle. The x value is going to be the angle measure. So sine is nowhere on this graph. Okay? Just keep that in mind. Your heights on this graph do not correspond to the heights on this graph. Y does not mean the same thing. Got it? That's really important. Okay? So here we go. We're going to use the same angle measures. X is your angle because x is inside of cosine. Okay? So my angle measures I'm going to stay with the same ones I just talked to you about. Even though I could go on forever in both directions, I'm just going to use the standard unit circle values that you're comfortable with to start with. Okay? So I'm going to start with an angle measure of 0. At the angle measure of 0, wait a minute, it would probably help if I put some tick marks on this thing to give me a frame of reference where to plot points. My angles go from 0 to 2 pi, so on my x-axis, which is marking my angle, I'm going to go out to 2 pi, all the way to the right. I have marked quarter pi units all the way through, so I really need to get down to quarter pi tick marks. So I'm going to split 2 pi's length in half and get pi. So however long your x-axis is, split it in half and put a mark that says pi. Split those sections in half and you'll have 1/2 pi, so pi over 2 and 3 pi over 2. If I split those in half again, I'll be down to quarter pi units, which is my table's values that I have. Okay, so this is going to be pi over 4, this would be 3 pi over 4, 5 pi over 4, and 7 pi over 4. My y values on this graph will correspond to my cosine values. Everybody look at the table of values that we made over here. How do I describe my cosine values? What's the largest and what's the smallest? What's the largest value you have and what's the smallest value you have for cosine?
1/2 pi.
For cosine, not for the angle, for cosine, bless you.
1 and 0.
-1's even smaller than 0 though.
-1.
That makes sense though, right?
Yeah.
Okay, so 1 and -1. So your graph needs to go maximum of height of 1 and minimum height of -1 take your y-axis, make a y value of 1 and -1 about equidistant from the x-axis on your y-axis, okay? Now, I'm going to split that actually in quarters, and you'll see why here in a minute. So the middle tick mark would be 1/2 or 0.5. This would be -0.5. That's just going to kind of give me a frame of reference for my heights here in a minute. All right? I should have done that with you before we started making the table. But now let's start making the table. So my angle of 0. If I plug 0 into my function, I get cosine of 0. What is the cosine of 0? If you go to your table or your unit circle, either one, the cosine of 0 is 1. So you need to plot the point 0, 1, which is right up here. My next angle is going to be pi over 4. What's the cosine value of pi over 4?
Square root of 2 over 2.
And that's really hard to graph. We would probably prefer a decimal. So the decimal of square root of 2 over 2 is 0.707 approximately. So we're going to put 0.7 in my table. To go to a height of 0.7, that's why I marked it in quarters, because 0.75 is a little bit higher than 0.7. So you need to go just shy of that 3/4 mark at pi over 4. Got it so far? All right, pi over 2 is the next angle that I've given you, and pi over 2 has what for a cosine value?
0.
Yes, so I need to have the point pi over 2, 0, so I need to be on the x-axis. All right, 3 pi over 4 has what for a cosine value?
-0.7.
So we're going to put -0.7, good. Okay, and I need to go negative almost to 3/4 of the way, which takes me right about there. Pi is my next angle increment. Pi gives me a cosine value of what? -1, very good. So your cosine value now is as low as it will possibly go. It's right there, okay? 5 pi over 4 gives me what for a cosine value?
-0.7.
Good, we're recording. So you can get the first half. 5 pi over 4 takes me back up to negative square root of 2 over 2, which is -0.7. Thank you very much. So I need to be back at the same height that I was a second ago. Okay, try to make them the same height, symmetric. 3 pi over 2 has what for a cosine value?
0.
0. So you should be back up to the x-axis at 3 pi over 2. 2 more. 7 pi over 4 gives me what for a cosine value? Positive 0.7. Very good. Square root of 2 over 2. So go to about the same, go to the exact same height as much as you can as you had over there. I think that's decent. Yep. And 2 pi has what for a cosine value? Back up to 1. And after that, you would continue to go around the unit circle, so your cosine values would start to repeat the behavior that they had from the beginning. I'm calling the y-axis the beginning, even though there really is no beginning. Okay, now all we need to do is connect the dots, just like we did back in preschool, to the best of our ability, just in a nice curve. Try not to have any corners in your curve. Okay, so here we go. I'm filling in this graph of cosine, and that right there is the graph of cosine. All right. We talked a second ago about cosine being cyclic. After 2 pi, you would have another value of like 9 pi over 4, and that would be back down to the value of 0.7. All right, so these are going to start to repeat. So this picture right here is actually going to be copied over and over and over. The picture's length, the cycle's length, is called the period, and the period is 2 pi for this. Just like wallpaper, you know, you've seen a pattern of wallpaper repeating. That's exactly what's going on here. you have a period cycle of 2 pi for cosine of x. That's how long it takes for your number pattern to repeat. Okay? Does this make sense so far? You now have a graph of only the cosine values of the angles from 0 to 2 pi. Again, this thing goes on forever, so it can keep oscillating in both directions, actually. Okay? There you go. So cosine starts high and goes low. Now let's talk about that just a little bit. Yeah, Courtney.
So if you did all of the like points from the unit circle, like the ones you didn't add up there, would they fall on the line that you made? Or
Yes. You mean the multiples of pi over 6 cosine
Yeah.
values? Absolutely. They will just be more points on this line. Does that make sense? It's a good question. The only reason I didn't do those is because then it becomes a little cumbersome when you're making the table.
yeah.
You can kind of tell the shape with just the pi over 4 lengths. It's hard to tell if you mark only the 0 and pi over 2 ones. It's hard to tell whether you have like corners or what, but you can see when you mark the pi over 4s that you have to curve stronger here than you did at the beginning. Okay, so that's one reason that I give you the quarter pi multiples. But the pi over 6 multiples just becomes a little bit much then. But yes, they would all fall on this line. On this curve, rather. Okay? Now, let's look back at the unit circle for just a second. Let me see if I can make this big picture for you before we go on to making the sine graph. The cosine values here are the x values, right? So look at just your x values. See if you can hone in on just your x values for a second. My x values start at 1, and then they shrink until they get back to the y-axis at 0, and then they go negative to 1, and then they come back to the y-axis at 0, and then they go back to positive 1. My heights should mimic that behavior. Okay? It's kind of like this. If you had a particle that was traveling in a circular motion around this unit circle, its shadow projected onto the x-axis would be translated into the heights on that graph. Okay, so it's like if the particle's traveling along this circle, I'm going from a length of 1 to a length down to the y-axis, which is a length of 0, and then over to a length of negative 1, and then back to a length of positive 1 again. Again, the heights of the lengths, the cosine values, are the heights on this graph. Does that make sense? Let's try graphing sine now. Okay, I'm going to shift this. Hopefully it won't make anybody... All right. I don't have the unit circle in the picture on the video now, but you have it on your paper, so here we go. The sine function. I'm not going to make a new table for the sine function because I think you can do it with everything that we've just talked about. All right, so I still need to mark 0 to 2 pi on my x-axis. So I still want my angle to be at 2 pi, furthermost on the x-axis. I'm going to split that into quarter pi units again. Okay. Just take a second to do that as well on your paper. So get it down to pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, and 7 pi over 4, and then 2 pi. My y values will go between what minimum and maximum heights. So my sine values here come from my sine values on the unit circle, which went between what values? What's my highest and lowest sine values on the unit circle?
The same.
Still 1 and negative 1, isn't it? So we're going to make a negative 1 down here and a positive 1 up here. And I know that my sine and cosine values are kind of copied at different points, so I'm still going to want 0.707 graphable, so I should probably mark 3/4, which is 0.75. Okay, just for a frame of reference. All right, let's start graphing sine of x. So sine at 0 has what for a value? What's the value of sine of 0?
0.
0. So I'm going to put a point at 0, 0. Next, the sine of pi over 4, I will sweep through 0.707 at pi over 4 on my way to pi over 2, which gives me a height of what on sine? What's the sine of pi over 2?
1.
1. So I should be at a height of 1 by the time I get to pi over 2, and I need to sweep through 0.707 on my way. All right? By the time I get back to pi, my sine value has come all the way back to 0 again, and I need to sweep back through 0.707 on my way at 3 pi over 4. After pi, my sine value starts to go negative on my unit circle, so I will have -1 as a height at 3 pi over 2, which is right about there, okay? And I need to hit -0.707 on my way at 5 pi over 4. Bless you.
Thank you.
I come back up to the x-axis of 0 by 2 pi, and I need to hit 0.707 on my way at 7 pi over 4. Make your sine curve. Here we go. No, it's not the best I've done all day today, but you get the idea. Okay? So there's your sine curve. Again, it is cyclic. How long does it take for the cycle of sine to repeat? 2 pi. 2 pi. Because after 1 pi, I don't have the same picture copied. Does that make sense?
She has mine.
Okay. So 2 pi is still the period length. Now let's talk about how these two graphs relate real quick. They look pretty similar. In English, we would say compare and contrast. So go ahead and compare and contrast these graphs. How are they the same? How are they different? Courtney.
It kind of looks like they just took the first graph, and moved it over.
How's it shifted?
Like it
So-
shifted like
This graph is that graph moved how?
to the right.
To the right,
1 pi.
not even pi.
It would be
1/2 pi. 1/2 pi, because look, if you take these 2 points as kind of whole place values, you need to move them over to right here to make the sine graph. So your sine graph has actually moved your cosine graph over pi over 2 units to the right. Let's go ahead and express that with transformations that we learned in chapter 2. Okay, so the sine of x will equal the cosine function shifted pi over 2. Does anybody remember how to shift to the right?
You do.
How do you shift a function to the right?
Subtract.
Subtract pi over 2. So we're going to subtract pi over 2 from x to shift to the right. And this is just an extension for today. This is not even totally part of what we were trying to get to today. Everything we were trying to get to today is on the board. But sine and cosine have the same type of shape. The only difference is that the sine value has been shifted to the right pi over 2 units. Go.
Why did we have to shift it to the right? Why couldn't we have shifted it left?
Because if I take this picture and shift to the left, it's going to put my heights at the wrong place. It's going to need reflected as well. And that takes an interesting concept. Why can't I shift left and reflect? And the answer is that you can. So if I reflect, I need a negative out in front, and I put a plus right here instead. That's actually equivalent to this value for the cosine function. Okay? Now, sine and cosine have similar shapes. We talked a while ago about how sine and cosine are often paired together. Secant and cosecant are often paired together, and cotangent and tangent are often paired together. Their graphs will mimic that. The sine and cosine shapes are the same. It's just a matter of where they're located. Tangent and cotangent shapes on their graphs will be the same, and secant and cosecant shapes will be the same, just for the record. Okay? All right.